Good day, everyone. You are welcome to my YouTube channel, Everything Medical. In today's video, we shall be appreciating the bony structure, which is called the radius, right? If you are coming across to my channel at the first time, don't forget to subscribe, like, comment, and share, and also tell your friends, your classmates, your classmates about our channel so that they will benefit from our videos. Now, let's proceed. Here on my hand is a structure and a bony structure called the radius, right? The radius is a long bone. It belongs to a classification of a bone called the long bone because it has two ends. That is the both ends, the upper proximal end and also the lower end, and it has a shaft. So one of the distinguishing features of a long bone is that it has two extremities or the ends and also the long portion, which is the shaft, right? The shaft. Now, the radius lies laterally and parallel along with ulna on the forearm. That means the ulna is situated medial while the radius is situated laterally on the forearm. So two of them are the two bones of the forearm. Just that the ulna is bigger while the radius is smaller. So that is why the radius is the second bone of the forearm, while the ulna is the first bone of the forearm. Before we delve into other features to discuss, let's quickly discuss the articulation of this bone. This bone majorly have four major articulations, two on the upper proximal end, while two on the lower distal end. Now watch. Here on the head, right, it has what we call a concave articular surface here. This is the concave articular surface of the head of the radius, right? Which it receives or articulates to the capitulum of the humerus to form humeroradial joint. And humeroradial joint is a participating joint that forms the elbow joint complex, right? So that is number one joint. We call it the humeroradial joint, which is an articulation between the concave surface of the head of the radius with the capitulum of the humerus, right? The next one is the provision that is made on the medial side of the head of the radius, which is here, which it articulates with the radial notch of the ulna in order to form the proximal radio-ulnar joint. So that is the next joint. And the proximal radio-ulnar joint is one of the participating joints of the elbow joint complex, right? So that is the two joints on the upper proximal end. Now watch this lower distal end. Now, this lower distal end has two joints also. One is found on the medial surface or the medial side of the lower end. The medial side of the lower end has a concave depression also, which is called the ulnar notch. The ulnar notch receives the head of the ulna, right? So this is the ulnar notch here. It receives the head of the ulna in order to form an articulation with the distal end of the ulna, which is called the distal radio-ulnar joint. That is the third joint. The next joint is on the distal surface. This distal surface has two articular facets, which receives two carpal bones. One is the scaphoid bone, while the other one is the lunate bone. So two of them participate to form the wrist joint. So that is the four articulation of the radius bone. Now let's quickly look at the ends before we go to the shaft and other features, right? So the upper end or the proximal end has basically three features. One is the head, two is the neck, three is this roughened bony impression, which is the radial tuberosity. Now, the head of the radius is a disc-shaped bony structure. You can see it's like a disc. It's a disc-shaped bony structure which has a concave articular surface in order to receive the capitulum of the humerus to form humeroradial joint. Medially on its head is a provision which articulates with the radial notch of the ulna to form the proximal radio-ulnar joint, which is here. And here is mortica. So the medial part of the head of the radius is mortica because of the articulation it made with the ulna. And that articulation is called the proximal radio-ulnar joint, right? Now, the next one is the neck. The next feature on the upper proximal end is the neck. Look at the neck here. The neck is narrow. You can see it's narrow, right? The neck of the radius is narrow. So it extends from the head of the radius to the radial tuberosity. That is all about the neck. You can see the neck is narrow, extending from the head of the radius to the radial tuberosity. Now, what is the next feature? The next feature of the upper proximal end is the radial tuberosity, right? Now, the radial tuberosity, which is here I'm pointing, is a bony projection or a roughened bony projection which provides sort of attachment of the tendon of bicep brachii. It provides sort of attachment of tendon of bicep brachii and is one of the steeplechase exam. What attaches at the mark point, they could mark the radial tuberosity. So what attaches there is the tendon of the bicep brachii, right? So that is all about the upper proximal end because it basically has three features: the head, the neck, and the radial tuberosity. The next is the shaft. The shaft is the longest portion of this bone, extending from the upper end to the lower end. And the shaft it is laterally convex. You can see it's as if it's convex laterally because here this bone is not that straight. So it's as if it's straight, right? And it has a sharpest interosseous surface. Look at it here. It's a sharpest interosseous surface. You can see it is sharp. It's very, very sharp, right? And it is more large on its distal end, on the lower end, right? The shaft has three surfaces and three borders. It has three surfaces and what? Three borders. So this is the medial surface of the shaft, which continues with the interosseous border. This is also the anterior border. This is the interosseous border. This is the posterior border, right? And we also have the posterior surface and also the anterior surface. So basically, it has three surfaces and three borders: the posterior border, the anterior border, and the interosseous border or the medial border. We also have the anterior surface, the posterior surface, and also the lateral surface. So that is how it works, the shaft. There are many muscles that attaches here, right? But muscles mainly attach on the ulna compared to the radius. That is the flexor muscles and the extensor muscles per se, right? Now, let's quickly look at the distal end on the lower end. The distal end on the lower end is usually expanded. You can see it is more bigger compared to the upper end. So it is usually expanded to form a triangular end. I mean a rectangular end. To form a rectangular end, you can see it is more bigger compared to the proximal end, right? So it is that bigger in order to form a rectangular end. And the lateral part of this end projects distally to form the stellar process. And this is the stellar process. You can see this is the lateral part. It projects distally, that is downward, to form the stellar process. Also, the medial surface of this end, which is the medial part of it, present a concavity, right, which is called the ulnar notch. I've explained it, which receive the distal end of the ulna to form the distal radio-ulnar joint or the inferior radio-ulnar joint. Also, it has what we call the distal surface, which is here, the distal surface, which has two facets to receive two carpal bones, the scaphoid bone and the lunate bone, which participate in formation of the root joint. We have the dorsal tubercle, which is usually from its dorsal surface here. Here is the dorsal tubercle, which can be called the Joseph Lister's tubercle, right? Look at it here. So it is found on its dorsal surface, right? So these are the features of the lower end of the radius, right? The radius basically has two ossifications, but it is primarily divided, right? So we have one primary center of ossification and two secondary center of ossification, right? So we can call it three centers of ossification. Two is secondary, one is primary. That is how it works. Now, let's quickly look at some of the common fractures of the radius. Number one is Colles fracture. Colles fracture occurs as a result of a fall from an outstretched hand. A fall from an outstretched hand, whereby the distal end of the radius is fractured here. Here is fractured. It will fracture, and if it fractures, the hand and the wrist will dislocate posteriorly, thereby presenting clinically deformity called Dinah's fork deformity, right? The hand will be like this. The hand will be on this manner. So it will present Dinah's fork deformity. So it is caused as a result of fall on a stretched hand. The next deformity is Smith fracture. Smith fracture is similar, like is opposite to Colles fracture, right? When it happens, although it is still a fracture on the distal end of the radius, but when it fractures, the hand and the wrist will dislocate anteriorly. Recall that in Colles fracture, they dislocate posteriorly, right? So that is how that one works, which is Smith fracture. The next fracture is the fracture of the head of the radius. Here, when it fractures. And that fracture of the head of the radius occurs whereby there is a forceful pushing or when there's a force of the head of the radius to the capitulum of the humerus, right? It will fracture the head of the radius because of the forceful push to the capitulum of the humerus. The next fracture, common fracture of the radius, is what we call the Mothengia fracture. When there's Mothengia fracture, it means there is a fracture of the proximal end of the ulna, thereby dislocating the head of the radius from the radial notch of the ulna. That means the proximal radio-ulnar joint will be threatened because already the fracture of the proximal end of the ulna, which will lead to the dislocation of the head of the radius on that joint, right? That means the joint is no longer existing. Do we get? So that is what we call the Mothengia's fracture, whereby there is a fracture on the proximal end of the ulna, thereby leading to the dislocation of the head of the radius to that joint. So we call it Mothengia's fracture. The next fracture is Gelazhi's fracture. That one is when there's a fracture on the distal end of the ulna, thereby causing a dislocation of the distal end of the radius from the inferior radio-ulnar joint, right? The next clinical deformity of the radius is what we call the Madelung deformity, whereby there is a congenital anomaly of the radius, right? Mainly affecting the ossification centers and all that. So, guys, that is all about the radius. Is a very simple bone. This is not that complex bone to discuss. So, thank you so much for sticking to the end of this class. I really appreciate it. Do well to share and invite your friends. Thank you so much for watching.